All right. So thanks for joining. Today we're going to, my name is Judd. I'm the product manager for the ASI Automotive Group. And today we're going to learn about the fun world of how robot drivers are changing the automotive testing industry. So I know that there's a lot of options out there, and definitely like the what they have to offer. And I believe that ASI robots do things that they don't, and they do things that we don't. And today we're going to showcase the ASI robots. So we'll be reviewing existing testing techniques employed in the industry and the limitations associated with those traditional testing methods. Then we're going to watch a short video presentation that explains the ASI robots, shows how they work, their working principles. And then after that, we're going to explore 5 case studies that showcase the application of the ASI driving robots in different scenarios and examine the techniques and the methodologies, the key benefits that allowed the customers to achieve successful outcomes. And we look forward to an engaging and informative session. Brooke and Eric will be monitoring the chat, or feel free to ask questions along the way. So we're glad you're here. Let's get started. So most proving grounds use a variety of techniques to approximate the desired test conditions for misuse, impact, durability, and even ADAS. So in some instances, they use a one-sided ramp to roll a vehicle, or a vehicle is sent down a rail and smashed into a pillar or a wall. Sometimes a system of pulleys are applied to drag the vehicle forward, or another vehicle into it, or into a structure. Sometimes we use test drivers, and they drive the vehicle over extremely rough roads for long periods of time, or subject them to intentional misuse scenarios such as excessive loads or aggressive driving, trying to evaluate the performance under extreme conditions and maneuvers. And computer simulation is also used, trying to replicate real-world scenarios and then assess the vehicle behavior, performance, and safety. But it's not testing in the real world. And any of you that use simulation maybe have noticed that things don't always work the same in the real world. So these techniques aren't adequate for today's world. They require complex safety measures to keep human drivers safe. They expose human bias and have known accuracy, repeatability, and efficiency limitations. And because of complexity, they don't fully simulate or test true-to-life scenarios. So how do product developers take confidence that they're addressing the right things, knowing that the data is skewed? It's not accurate to real-world scenarios. We're doing the best we can. They're unable to time actions and multiple actors within millisecond accuracy, and all of this results in bad data. So there's the problem. Now let's watch a quick video that showcases the ASI driving robots and how they work. All right. So now we're going to dive in to some of those case studies, and some of those were highlighted in this in that video. So here's two examples from the accelerated durability. So we had a major OEM proving ground, and they weren't sure if they wanted to invest in more robots. At the time, they had 4 driving robots along with our Mobius command and control software. And they ran a blind test without telling anybody what they were doing. So they gave a test profile to their human driver group with instructions that they were to work 24 hours a day, 7 days a week to complete the profile as quickly as possible. They gave the same profile to the group that runs the ASI driving robots, and it took the human drivers 11 days to complete the profile, working 24 hours a day, 7 days a week. And it took the ASI driving robots team 7 days to complete that same profile. And at another proving ground, they had a very tough track, a very rough accelerated durability track. And this one, they wanted to test a roll cage for a customer, or a cargo bar for this customer. And this proving ground, they could only run drivers during daylight hours. They were limited to how long a driver could be in the vehicle because of how rough the track is. So they quoted their customers 6 to 8 weeks to complete this test with the human drivers. And on day one, 2 drivers were hurt and sent to the hospital. And they put the robot in there, programmed up the path, and the robot was able to complete that profile within 11 hours. Their customer just couldn't believe it. They were expecting 6 to 8 weeks to complete this test, and here they had results in 11 hours. Our customer said that their customer came in, and when they saw that, they were jumping, literally jumping up and down and patting them on the backs for being able to complete this. And they did have the 2 injuries originally, but were able to save some of their human drivers from that rigor of that testing. So robots provide superior efficiency and speeds. They can outperform the human drivers, completing tasks in significantly shorter time frames. The robots can work 24/7 without fatigue or limitations, delivering continuous operations, superior efficiency, and better performance. So our robots have been built from the ground up for unmatched durability and adaptability. They've got an IP66 rating and mil-spec design that ensures resilience to the harsh conditions and abuse. And they're easily transferred between vehicles, uh, utilizing extra durable connectors for long-lasting performance. They also, ASI's 19-pound steering robot provides reliable, accurate, and repeatable steering, and can be unmounted easily from a vehicle without losing calibration. So if you need to transport that somewhere else. They have a powerful 2,000 degree per second max speed and 60 nanometer max torque that enables precise control and reliability in a variety of vehicles and situations, even on those difficult advanced durability tracks. The advanced actuation capabilities provide command of throttle, brake, steering, automatic transmission, and redundant brake systems. And they have an adaptable stroke and force capability that allows our robots to accommodate large and small commercial, passenger, and off-road vehicles for their difficult testing scenarios. So leveraging the ASI driving robots, you can accelerate project timelines to reduce testing durations, and this saves valuable time and resources. You can experience an increased productivity and achieve remarkable results with consistent performance, and they help to minimize the risk of injuries, errors, and bias associated with human drivers while benefiting from enhanced safety and reliability. So another example, we had a customer with a highly precise drive profile that their vehicle needed to follow, adhering to specific speeds and staying on a designed path of potholes. Human drivers frequently struggle to meet the required accuracy threshold of 78%, resulting in laps that didn't count and requiring them to make it additional laps. they couldn't keep the three tires in the potholes and maintain the speed profile with adequacy, and required them to continue taking that beating so that they could get the number of required laps. However, with the driving robots, the accuracy reached an impressive 97% adherence to the test profile at the end of an 8-hour shift. This remarkable level of precision ensures more accurate and reliable data, significantly reducing the need for repeated tests. And by leveraging the robotic capabilities, automotive testing becomes more efficient and streamlined, allowing for faster completion of those testing cycles. The ASI driving robots deliver unparalleled precision and accuracy, surpassing the human capabilities. They provide reliable data collection by providing precise and consistent data for informed decision making and the optimization of engineering outcomes. And you can conduct comprehensive testing with ASI driving robots, which reduces the need for repeating tests or laps and accelerating project timelines while maintaining thorough and efficient testing. And leveraging our cutting edge technologies, you can optimize your efforts while at the same time enhancing safety and performance to achieve superior engineering outcomes. So some of those technologies is we use a Trimble BX992 GPS that provides multi-constellation GNSS support. It's IP67 rated. It's got dual antenna inputs for precise heading calculations, centimeter level position accuracy, velocity control for precise speed adherence, and an open framework that we can use. We also use the Ragent breadcrumb for uninterrupted data transfer and high security standards and compliance. They have a variety of broadcast frequencies for high-speed connectivity and have built-in redundancy for exceptional reliability. So another example, this is kind of funny. We had a customer approach us with a daring question. Could our driving robots withstand the impact of driving off of a 1 meter high angled ramp? And we responded, we don't know. So a lot of times we train our customers on how to set up their own tests. And we often will get, these questions about, hey, how would we do this? Or we just did, in this case, we said, we don't know. And they said, it did great. It did great. We didn't even know. We trained them how to do it and they set it up. They ran it. For human drivers, they have to have somebody that has a special certification. They've got to modify the vehicle. They got to put a roll cage in there, put a fire extinguisher. The driver's got to have PPE, a 5-point harness. They've got to have emergency vehicles scheduled and on site. It takes a lot to get that set up. And with our robot, it did great. We didn't even know it. The driving robot was able to navigate the ramp with precision. This showcases the remarkable capabilities of how our customers are safely pushing boundaries. So again, that OEM, they had one driver that was certified to do this test, and they would fly them all over the world to perform this test at their different facilities. But with the ASI driving robots, they provided certification-free operation. They didn't need special certification for their drivers, and it helped to reduce the logistics and the costs of running this test. And it helped to eliminate the risks associated with human drivers in these hazardous scenarios. So the Mobius command and control system has multiple safety protocols built into it. There are multiple user profiles that you can set up, as well as security levels. It's got tools like geofencing, map boundaries, drivable areas, obstacles, and you can put constraints on your paths. We do proximity and vehicle monitoring. And we've got an e-stop that can be commanded remotely from the command center or while you're in the vehicle. We also have optional integrations with third-party tracking systems like RTS and Motorola, and these allow us to show autonomous and human assets inside of our software. This also, our programming Mobius automatically gives priority to human assets and are used in proving grounds, mining, ag, construction, and military ecosystems. I'll just add that our Mobius software was built from the ground up uh, as a platform where we service these different vertical markets, which brings value into our software. For example, things that we can do, we can reverse vehicles, including with trailers because of our logistics uh, business unit. So we get a lot of value from those other units that are actively developing their platforms as well. We also have an optional compatibility with the Mobileye camera that allows forward collision and pedestrian detection warnings to be floated up to our safety systems. All right, and our last example. So a major car manufacturer required a safe way to test their L2 plus ADAS in real world conditions. So in simulation, they'd specified thousands of simulated scenarios, and they designed 16 tests where they wanted to use 3 to 5 target vehicles choreographed around their L2 host from speeds of 25 to 70 miles an hour. So that's 40 kph to 115 kph. They felt if they could replicate these tests at least 3 times while mixing up the fleet of vehicles in different lanes during the scenarios, that would be enough to validate the simulation results in the physical world. And this way they would feel better about and better equipped to put the safety rider in the vehicle and do the testing on the public roads. But the test became dauntingly complex, riddled with concerns of operating multiple vehicles in close proximity, accurately, trying to get the repeatability of running those scenarios exactly the same each time. And these scenarios were designed to test multiple aspects of the L2 plus ADAS each time. For example, lane keep assist with the ACC and traffic jam assist. And they were observing differences in how the L2 plus performed in the real world versus that simulation. So ASI swarming with driving robots was the ultimate solution. Our customers are able to export scenarios from simulation and import those into our swarming solution. And then our robots are commanded to drive the exact simulation scenarios, and they will do it over and over without increased stress or fatigue. And with this additional confidence in the reliability, variances were narrowed into the engaged L2 plus so that the algorithm engineers would have an unbiased, repeatable data for perfecting their solution and its integration in the platform. Our robots also provided a valuable service as an autonomous safety rider during these tests, and they were ready to take control if safety parameters were exceeded, and they would take over and command all vehicles to come to a safe, controlled stop using V2V communication that we call smart stopping. During the final test, the OEM planned 8 days to validate their L2 plus, but with the ASI swarming and driving robots, they were able to complete the tests in less than 1 week. Originally, they anticipated running 1 test in the morning, 1 test in the afternoon, and run through their schedule. But with the driving robots, they didn't encounter any failed scenarios, and they were able to switch up the placement of the vehicles in those tests. It was amazing. So ASI driving robots drive exact simulation scenarios repeatably with safety and precision and without stress or fatigue. This helps to narrow the variances so that engineers can focus on perfecting their L2 or L3, L4, L5 ADAS instead of fiddling with inadequate testing techniques. Driving robots help to mitigate the risks and provide precise navigation, even in close proximity to other vehicles. They minimize human driver injuries and ensure enhanced safety in engineering operations. They help to accelerate testing timelines, like in this example where the tests were completed in less than 1 week instead of the planned 8 days. Precise choreography of the multiple test vehicles to match the simulation was done with the push of 1 button. rather than trying to coordinate with multiple human drivers. And this allowed for quick advancement from one test to the next without encountering failed scenarios. You can also get accurate real world replication of simulation scenarios with exceptional precision and consistency. And this enables the algorithm engineers to focus on perfecting their solution based on reliable data. So, along with smart stopping and being an autonomous safety rider, our system also includes the abilities for detecting timing and positional errors for accurate navigation and performance evaluation. They also allow a customizable tolerance of the off track conditions, which enhances safety and adaptability. So, in summary, let's boil this down. ASI driving robots outperform human drivers. They can complete tasks in shorter time frames. Precision engineering advancements surpass human capabilities, ensuring more precise data collection and uh, informed decision making. ASI robots enable engineers to navigate challenging terrains and hazardous environments with exceptional reliability. Safety protocols such as smart stopping, autonomous safety rider, and those built into ASI's Mobius software help to mitigate risks. Innovative technologies like the Trimble BX992, the Ragent breadcrumb, our compatibility with third-party tracking systems and Mobileye camera contribute to additional safety, redundancy, and repeatability. By adopting ASI driving robots and leveraging their strategies, technologies, and safety measures, automotive manufacturers can achieve uh, accelerated efficiency, enhanced safety, and precise engineering outcomes in their testing operations. Oh, hold on. So these successes are made possible because of collaborations with customers to overcome testing challenges and a willingness to safely push boundaries. We want to help all of you test beyond the typical engineering practices and get started with driving robots today. And I see that there's a question here. Can you answer this question? And this is the end of the presentation. My contact information is here. Also, Eric Budd. And so, yeah, we are open for these questions.